Hello, good evening. This is AHATube. Now, example 2 on kinematics and dynamics of particles. Now, the example says a particle moves along the x-axis as a function of time. Xt is equal to 6t squared plus 4t plus 3 meter. Then determine total displacement for the time interval of 0 to 3 seconds, and average velocity for the time interval of 0 to 2 seconds, and velocity as a function of time, v instant at t is equal to 3 seconds, and finally it says draw the SAT and VT graphs. Now, the given here is the equation for distance with respect to t. Okay, here we have the given distance with respect to t. Okay, the object is moving along the x, so 6t squared plus 4t plus 3 meter. Okay, it's 3 meter. Then a now displacement for the time interval of 0 and 3 seconds. So total displacement is equal to displacement final minus displacement initial. Now the displacement final is the final displacement, okay, at which the time is 3 seconds. Okay, displacement at 3 seconds minus displacement at 0 seconds. So this is equal to, we replace 3 instead of t, so that this is going to be, okay, let's say it's better to represent with x. Okay, x. So now this is 6 into 3 squared plus 4 times 3 plus 3 in meter minus x at 0 is 6 times 0 squared plus 4 times 0 plus 3 again meter. Now this is simply 0. Again, this is 0. Now this is equal to 6 times 9 plus 4 times 3 plus 3 meter minus 3 meter. Now this is 54 plus 12 plus 3 minus 3, so that 3 cancelled out. This is equal to, okay, x total is equal to, this is 66 meter. Okay, the displacement for the time interval of 0 to 3 seconds is 66 meter. Now the other one is average velocity. Okay, VAV for the time interval of 0 to 2 seconds. VAV is equal to change in x, okay, divided by change in t. We know that change in x is equal to xf, okay, minus xi, okay, divided by vf minus ti. But what is our xf and what is our xi? Okay, our xf is this is equal to, okay, x at a time of 3 seconds minus x at a time of 0 second divided by our times r. Okay, this is 3 final minus 0. 3 minus 0. So what is the location of the object, the position of the object when the time is 3 seconds? And what is the position of the object when the time is 0 second? Okay, is our big question. So this is equal to, Now x3 is to mean, okay, 6 into 3 square minus, oh, is that 2? Okay, 2. Okay, 2 squared minus, sorry, plus 4 times 2 plus 3, okay, minus 0, 6 times 0 squared plus 4 times 0 plus 3 meter divided by 3 minus 1, 0. Now this is 6 times 4 plus 8 plus 3 minus, these are zeros, so minus 3 divided by, the difference here is 3. So 3 is taken, then this is 24 plus 8 is 32. This is equal to 32 divided by, sorry, this is 2, okay, divided by 2, this is 16 meter per second, VAV. Okay, the average velocity for the time interval of 0 to 2 seconds is 16 meter per second. Okay, now the next is C, V as a function of time. How do we express V as a function of time? So C, V as a function of time. Now here, V is equal to change in x divided by change in t. This is equivalent to dx with respect to t divided by dt, differentiating the displacement with respect to t provides velocity with respect to time. Now this is equal to d, our x is okay, x with respect to t is t squared plus 6t squared plus 4t plus 3 divided by, okay, differentiating this with respect to t. So this is equal to v is equal to, now d by dt of 6t squared is 6 times 2 t, 2 minus 1, okay, plus, now this is 4, okay, plus 0. So this is equal to 12t plus 4 is v with respect to t. 12t plus 4 meter per second, okay, in meter per second is v with respect to t. Now, here the other question is v instant d, v instant at t is equal to 3 seconds. This is question D. Instant velocity at a time of, when the time is 3 seconds. Now here v instant at a time of 3 seconds. Since we have this formula, okay, we can simply replace 3 instead of t, so that it gives us this, okay, v instant, v at a time of 3 seconds is equal to 12 times 3, okay, plus 4. This is equal to 40 meter per second. Or let's check on the other way. Okay, V instant. Okay, V instant. Now instant is equal to limit of actually limit of this, okay, limit of ds dx, okay, t over dt as changing t approach to 0. If it works, okay, actually it works, okay, changing t. This is equal to limit of now s, okay, s, I think it's a long process, t plus change in t, or x, okay, x minus x as okay, the time is t, change in t approach to 0, changing t approach to 0. This is equal to limit of instead of t we put t plus change in t, so 6 into t plus change in t squared plus 4 times t plus change in t plus 3 minus 6t squared plus 4t plus 3, okay, divided by change in t as change in t approach to 0. Now this is equal to limit of 6 into t squared plus 2t times change in t plus change in t squared, okay, change in t squared plus 4 times t plus 4 times change in t plus 3 minus 6t squared plus minus 4t plus still minus 3 divided by change in t as change in t approach to 0. Now here this is going to be 6t squared, so that 6t squared is cancelled. Now again 40 is cancelled, and 3 is cancelled out. Okay. So this is equal to limit of this is 12t, okay, 12t plus this is 12t change in t plus this is 6 change in t squared, okay, plus 4 change in t divided by change in t as change in t approach to 0. Now the change in t's can be cancelled out by the change in t, okay. Now the change in t's, okay, this is equal to limit of 12t, okay. Here we have change in t into change in t, 12t plus here we have 6 change in t, okay, plus 4 divided by change in t as change in t approach to 0. We took out change in t as common, okay. This was change in t, 12t change in t. This is, okay, change in t is taken as common. Then change in t can be cancelled out by this, okay. This is equal to okay, limit of 12t plus 6 change in t plus 4 as change in t approach to 0, okay, as change in t approach to 0. Now our time is 3 seconds. okay, 3 seconds, so that this is approaching 0. So t is equal to 3 seconds, implying that 12 times 3 plus 4, this is equal to 36 plus 4, which is equal to 40 meter per second. 40 meter per second. Okay. This is equal to 40 meter per second. So this is the instantaneous velocity at a time of 3 seconds. This is to show you how we can find another way the instantaneous velocity. Now part E of the question says draw the xt and vt graph, displacement, okay, displacement time graph and vt graph. Now the simpler way here is tabulating, okay, making a table. Now our equation for the displacement vector is 60 squared plus 40 plus 3. Then we tabulate this. Now here we have t in second and x t, okay, x with respect to t. So we can have 1, 2, 3. Then now when the time is 0, second, 0, 0, the displacement is, or the position is all at 3 meter, okay, at 3 meter. When the time is 1 second, okay, 1 second, 6 times 1 square is 6, plus 4 times 1 is 4, so 6 plus 4 is 10, then 13, okay, at 13 meter. When the time is 2 second, 2 times 2 is 4, 24, this is 24, okay, plus 4 times 2 is 8, plus 3, this is 32, 35. When the time is 3, now 6 times, this is going to be 9, 9 plus 4 times this is 12 plus 3, this is 54, 54 plus 12 is 66, 69. So by having this, we can draw the graph, the st graph or the xt graph. Now this is vector x, okay, with respect to t. This is our time. Then 1, 2, 3. When it's 0, okay, when it is 0, the displacement is 3 meter. Let's say this is big, okay, big, so that let's say this is 10, 20, 30, 40. This is enough. Okay, when the time was 0, the displacement was at 3 meter. Let's say 3 meter. When the time is 1 second, okay, 1 second, the displacement is about 13 meter. When the time is 2 seconds, the displacement is 35, 2, 35, and 3. Okay, so this is an upward parabola, okay, a half parabola with this nature. Okay, sorry for not meeting the points. Okay, this is a curve of this nature. Okay, curve of this nature. The curve would be seen more if the time space that we took is large, meaning if we took this, okay, t, x, t, 0, 5, oh, it's becoming big, okay, 2, 4, 6, still it's becoming a very big number, but the curve would be seen, okay? The curve would be seen. Okay, this is the curve. Now, now the VT graph is here, and the formula for the velocity is calculated as 12t plus 4. This is v with respect to t, and this is t. Now again, look, t, v with respect to t. 0, 1, 2, 3. Now when the time is 0, the velocity had been 4 meters per second. When the time is 1 times 12 is 12, plus 4 is 16 meters per second. When this is 2 times 12, 2 times 12 is 24, plus this is 28. When this is 3, this is 36, 40 meters per second. Meter per second. Let's see what's going on, okay? Now this is 1, this is 2, this is 3, okay? Let's make, okay, this is 1, this is 2, this is 3. Now again here, okay, 10, 20, this is 30, then 40. Now 0, 4. 0, 4 means when the time was 0, now the velocity had been 4 meters per second, nearly half of this. Okay, 4 meters per second, 4. When it's 1, this is 16, 16. Okay, this is 16, 16 meters per second, 16. Okay, closer to here. And when it's 2, this is closely, okay, closely, okay, this one. When it's 3, it's 14. So this is a linear graph. The graph of the VT, okay, the graph of VT is a linear curve. Now sorry for not matching this point, okay? This is a linear curve. This is V is equal to, this is a VT graph, V is equal to 12t plus 4. Again here, we shouldn't forget to write the formula, okay? X is equal to 6t squared plus 4t plus 3. This is the displacement time graph, and this is the velocity time graph. Thank you for watching. This is AHATube, okay? AHATube, your partner in academics and engineering, in maths and physics. Do not forget to like, share, and subscribe on AHATube so that we'll keep in touch. I appreciate for watching. Thank you very much. There are a lot of examples on AHATube, especially for you freshman students. Physics and mathematics examples and supplementary questions are on AHATube. So you can search the question in demand or the topic in demand by inserting the topic of your question. Thank you for watching. Keep in touch. Thank you.